All right, so today we're going to start a new topic. It's systems of inequalities. So a system is two equations or inequalities and how they interact with each other. Now when we get to systems of lines, our solutions are going to be very specific. But last week we talked about inequalities, and remember we had dotted lines, which mean we cannot include the points on the line. We had solid lines, which means we can include the points on the line. And then we also had to remember to shade below or above, depending on what the inequality sign was. Now, if we wanted to, we could totally figure out what this equation was. So for example, this equation right here is y. It's shaded below, because you can see here it's shaded below, so y is less than. It's got a solid line, so it's less than or equal to. If I look for my slope, I see rise 2, run 3, rise 2, run 3, rise 2, run 3, so it's 2/3 x, and my y-intercept is plus 3. For this line here, I'm not sure what my slope is. I see a point there. I see a point here. Okay, so I have y. For this one, they're shading above this inequality, greater than, but it's not equal to. I can't include the point on the line. Y is greater than. My slope is negative 1, 2, 3, 4. 1, 2, 3, 4, 5. Next, let's just check 1, 2, 3, 4. 1, 2, 3, 4, 5. There's another one. If I continue the pattern, I'm on track. And then my y-intercept is -1. Okay, so just a reminder, this is how we write inequality equations. So what we're going to look at today is, we're not just going to look at inequalities that represent, about solutions that represent one inequality. A system is where I have more than one line or equation graphed at the same time, and I'm looking for what they have in common. Okay, so let's look at this example. The We Got Tablets website plans to purchase ads in a local newspaper advertising their site. Their operating budget will allow them to spend at most $3,000 on advertising. An ad will cost $50 to appear in the weekday paper and $250 to appear in a weekend edition. They plan to run at most 25 ads. Okay, so there's a lot of information here. There's more information than we have. There's more information than we need to write one equation. There's actually enough to write two. So if I look at this, I've got money, money, money. Okay, so let's say I have weekend ads and I have weekday ads. So X is weekend, Y is weekday. How many ads do I have? At most 25. So if I think about that, if I have at most $25, can I have more than $25? No. Can I have exactly $25? Yes. So I can have less than or equal to 25. So all of my ads, my weekly and my weekend and weekday ads have to add up to 25 or less. Okay. Now, I've also got money. Okay. So my weekend ads cost $250. My weekend ads, so 250x plus my weekday ads are 50y. And that has got to cost, at most, once again, at most $3,000. Let's see if I got that right. Woo-hoo, go me. Okay, so this is a system. A system is when I have enough information to graph two things, and I'm trying to find the overlap. I'm trying to find out what makes both of these things true. So I don't just have to have 25 ads or less. I've also got to spend $3,000 or less. I have to satisfy both of those conditions. Okay? So let's look at this. Before we can graph these, they have to be in slope-intercept form, and we have talked and talked and talked about this, okay? So to turn this one into slope-intercept form, I need to get y by itself. So I'm going to subtract x from both sides. I have y less than or equal to negative x plus 25. And again, if you want to put the invisible 1 there, you can. Okay, for this one, same thing. I want to get the y by itself. So I'm going to subtract 250x from both sides. I have 50y less than or equal to negative 250x plus 3,000. Okay, so now I need to divide everything by 50. Do I need to flip my inequality sign? You're all saying no. Okay, we are not having a Dora the Explorer moment here, but hopefully you're all saying no, we do not need to flip the inequality sign because we're not dividing by a negative. So I have y less than or equal to negative 5x, I don't know, 3,000 divided by 50 plus 60, okay? So these are the two inequalities that I'm going to graph, okay, right there, okay? Now that I've got them written in slope-intercept form, and I'm going to put my little 1 there because you know I like to have my slope in rise over run format. I need to have a number. We're going to graph these, and we're going to see what they have in common. Okay, so first of all, if I graph this one, I have y less than or equal to negative 1x plus 25. So that means my m is negative 1 over 1. My b is 25. I'm shading below, and I'm going to have a solid line. Okay, so I'm going to start at 25, which looks to be right about there. Oh my goodness, seriously, this is crazy. I'm going to fall 4, run 4. You've got to pay real close attention to where your, to what your intervals are. Golly, I'm having trouble making words, y'all. Okay, so there's our table. Okay, so now, can I connect this line? Should I connect this line? Absolutely, I should connect this line. I don't have a ruler, so I'm going to find something to connect this line with. I'm going to use this Papermate pen box because a straight edge is a straight edge, okay? So now I'm going to actually connect this line. Now, I'm shading below, so I'm going to shade. Now, remember last week I told you I wanted you to shade like this. This is going to, right now, I'm about to show you the magic. It's about to happen, okay? So now I'm going to do my next one. Again, I have a solid line, and I'm shading below it. My slope is negative 5 over 1. My y-intercept is 60. So I'm going to put a dot on 60. Oh, my gosh, seriously. I'm going to go down 5 over 1. Oh, my gosh. I'm going to go down 10 over 2. Down, holy smokes, down 10 more over 2. Over 2, down 10 more over 2, down 10 over 2, down 10 more over 2. That does not even seem right, but whatever, it's what I'm doing. Down 20 over 4? Yeah, that works. Down 20 over 4. Down 20 over 4, down, okay, all right, we're going to connect this. This is the most awkward graph in the whole wide world. Like, it could not be, I mean, it could be more awkward, but I don't really know how. Now, let's just pretend that that is not the craziest line we've ever seen. Now, we're looking for the overlap, and as you can see on the graph that they actually graphed for me, we did actually graph this correctly, okay? So, now we're going to graph, and I'm only doing this so that I can graph this, do this easier. We're going to make our lines go the opposite direction, okay? So now, I've got two lines. I've got two inequalities graphed, okay? So the stuff that I want is in this area right here where they're double shaded, okay? I like to highlight it because I like it to really jump out at me, but y'all don't have to. It just needs to be obviously double shaded, okay? But seriously, you're going to love the highlighter if you choose to do it, okay? So the solution to a system of inequalities is the shaded area that satisfies both inequalities. So when we see right here, this area, both of these, so anything, because remember on this one, anything below is going to work. For this one, anything below is going to work. And this works for both of them. So anything in that double shaded area satisfies both inequalities. So if it says 515 falls into the area that's shaded by both inequalities. So it's one of the many solutions. So if I go over 5 up 15, boom, it's right there, and that is in the double shaded area. I could also check that by substituting. 15 less than or equal to negative 5 plus 25. 15 is less than or equal to 20. That is true. And then 15 less than or equal to negative 5 times 5 plus 60. 15 is less than or equal to negative 25 plus 60, which is 35, and that is also true. So both of those, so not only is it in the double shaded area that we look for, it also makes both of these inequalities true, and so that makes it a solution to this system.
Elizabeth, Mattea, if you're in the building, please come to the front office.
Okay, she's going to go to the front office, don't worry. So that's what we're looking for. We're looking for solutions that make a system, like I said, is an inequality or an equation where we have more than one equation or line or something happening at the same time, and we're looking for a solution that satisfies them both. Okay? Now, let's look when we plug it into the original inequality. So we had 5, 15. Let's see what happens if we put them in the original inequality. 5 plus 15 is 20. That is less than or equal to 25. 250 times 5 plus 50 times 15. Boy, we are going to need our calculator for this one. So 250 times 5 is 1,250. 50 times 15 is 750. We add them together, we get 2,000, which is less than or equal to 3,000. Okay? So not only does it work in our inequalities that we converted into slope-intercept form so that we could graph them on this crazy graph, it also works in our original equations. So we know that this is a correct system. So now, remember, when we talk about algebra, one of our goals in algebra is to make sure we understand everything about that value. So what does the point 515 mean in this situation? Okay, so again, if we go back to our original situation, we're going to buy ads in a paper, and they're going to buy weekend and weekday ads. Okay, so the point 515 here means that I can buy 5 weekend ads and 15 weekday ads. And what was my goal? I wanted to do less than 25 ads, 25 or less, and less than 3,000 on advertising. That is 20 ads, and it is, oh my gosh, what did we just say? We just said that that was $2,000 on advertising, which is less than 25 and less than 3,000. So this point, this value, 515, says that if I run 5 weekend ads and 15 weekday ads, I will have less than 25 ads and it will be less than $3,000, which is exactly the kind of points that we're looking for.